All right, for day 2 of this stuff, there's one additional part that I need to go through with you from yesterday, just because of the fact that some of the times the scores, like let's say it's, dealing with whatever score, and you have the standard deviation being that. Yesterday is all those were one of the ones where you added or subtracted the same number every time, and it was on that list. What happens if they're not? And then the other thing that we're going to talk about is you're going to look at graphs and you're going to tell me whether or not they're skewed left, skewed right, or if they're normally distributed. Okay, so it's a pretty short thing today. It won't take very long. It's mainly there's 2 parts, but mainly the one part is the heavier part. The other part is just looking at graphs and seeing what you think. So first thing that you're going to need is what happens when you're looking at a score and the number isn't officially on that list, that number line that we had. You're going to use this formula. The formula is z-score equals x minus the mu divided by the standard deviation. Okay. To find the z-score of the data, you take the number that you're looking for, subtract the mean from it, and then divide it by the standard deviation. Then, on page, the x will be a number, yeah. Sure, you can put the number sign, that would be okay. Now, the thing that you're going to need is on page 598, okay? What's on 598 at the top is a big chart. You will use that in order to find your answers. Those answers that are on the chart are reading the curve from left to right. So when they give you all those decimals, they're telling you the percentages that would go from all the way to the left side up to wherever the mark is that you're looking for. Okay? So here's the type of question that you're going to have. It's going to say something like, a study finds that weights of infants at birth are normally distributed with a mean of 3,270. So it's giving you that the mean is 3,270. And a standard deviation of 600 grams. So it's giving you those 2 pieces. It says an infant is randomly chosen. What's the probability that the infant weighs 4,170 grams or less? Okay, so this is the trick with this one as compared to yesterday's. If I gave you this problem yesterday, we could put 3,270 in the middle, add 600, add 600, add 600, or subtract 600, subtract, subtract, and those numbers would be on my number line. They're not today. So again, what we're going to do is we're going to use that z-score formula. The number that you're looking for weighs 4,170 or less. That's the question that you're trying to find. So the number, as Alan, like you said, can I just put the number symbol? The number is, or in this case, the x would be the number that they gave you, 4,170. Minus, what's the mean? 3,270, and then divide it by 600. Now, when you put this in your calculator, be extremely careful. Because what happens to a lot of people is they put 4,170 minus 3,270 divided by 600 without any parentheses whatsoever, and that will calculate it wrong for you. Because it will do the divide part first and then the subtraction after. If you put the top in parentheses and then hit divide by 600, or as somebody first hour said, can I get the answer for the top first and then divide that by 600? Yes. What number comes out?
1.5.
Good. So you have 1.5. Now, what you're going to do with that 1.5 is you're going to now turn to that table that's on page 598, and we're going to look up the number that is associated with 1.5. So here's how we do that. So here's my table. And the way this reads is if you look on the very far left, it says Z, and it's got -3, -2, -1, -0, 0, 1, 2, 3. since we're at the number 1.5, we go down to the row that has a 1, and then we go over to where it says 0.5. What number is associated with 1.5? 0.9332. Good. So again, just looking at straight off the table, we got 0.9332. Now let me explain what that means. That means that if I go everything from the left side of the data up to that number, that's 93.32% of the data. So on the like if I were to draw the picture that would go along with that, it said that it was normally distributed. So I'd have this little thing here. This would be 3,270 in the middle. Somewhere out here would be 4,170. And if we want everything less, that's all this. That's what the table's telling you. The table tells you from the left to the stopper. The stopper was 4,170. Okay? So for our answer for this problem, we are at 0.9332. That's my answer.
That's it?
That's it.
What's the... Oh, hold on. I get it. What does this have to do with the...
What does what have to do with what?
I don't know why you drew the thing.
Why I drew the picture?
Yeah.
Just to show you like what it would look, what it's doing.
Okay, so
You don't have to draw the
what's
picture.
point of the 9?
What 9?
Okay.
The 0.9332?
Yeah.
That is your answer, Alan. That is a percentage. 93.32% of babies.
This
Yep. Yes. 93.32% of babies are born 4,170 grams or less.
How many pounds? So should we write it as a percent?
You can do either one. I would take either way. Okay? Let me give you another one. Study finds the weights of infants at birth are normally distributed with a mean of 3,270 and a standard deviation of 600. Now, my guess is they didn't make those numbers up. Somehow, some way, they got those probably from a medical journal of some sort or study. Okay? An infant is chosen at random. What's the probability that an infant weighs at least 2,790 grams? Now, we need to talk. What does at least mean?
Greater than.
It's going to be either that or higher, correct? Or greater than. At least means that's the lowest it could be. If it said at most, that would be less than, right? So, the 2,790, if I were to list out all the different pieces and add and subtract 600, would not be on there. Okay, so that's why we have to use the z-score thing. So what's the number that we have to put in?
279.
Minus, what's the mean?
327.
Divided by 600. And when you type that into your calculator devices, what number spits out?
-0.8.
-0.8. Now, this morning, first hour, they asked me if that was right because can it be negative? Yes, it can. That just means that you're going to the left of the mean. Okay? Now, if you use the chart on page 598, when you look at negative 0.8, you go on the chart to where it says -0, and then over to 0.8, and what number? 0.2119.
That's it?
Now, this is not the answer. The reason why this is not the answer is because, remember, the chart reads this way. The chart reads from left to right. So that would be 0.2119 up to this point. But you told me that at least means greater than that number. Greater than would go this direction. So here's my thing for you. If you know that 100% of the data is here, and I have a line at 0.2119er, how would I get the other side of it? Subtract it from 1. Very nicely done. So for this particular thing, if I want to find the purple side, I would have to take 1 minus 0.2119. 0.7881. Today, you're going to have to subtract if you want to find the right-hand side of it. So I added an extra step now. Instead of just adding, you're going to have to subtract.
So you have to subtract if it's at least?
If it's going on the right-hand side, yes. So like on the number line, like here's this 0.2119 that's up here. That's what the chart tells you up from the left side up to the stopper. But if you want the right-hand side, you're going to have to subtract.
So we're only subtracting when it says like at least?
Right.
And just 1 minus your decimal?
Yes. Okay. What do you think?
Good.
Yep. Now, that's the first part. Biggest thing is make sure you get the right decimal out of the chart, and then remember that it reads from left to right to wherever that stopper is. Okay? Good.
I'm trying to figure out where the 0.2119 comes from.
The chart in the book.
Oh.
Page 598.
Why do you subtract it?
Because you want to find, when it says at least, the chart only tells you up to from the left to the right, like less than. When you say at least, you want greater than, so you want the right-hand side. So that's why I have to subtract it from 1. Okay? And the last thing that you're going to do is they're going to give you graphs, and they're going to ask you what type of distribution this is. You have 3 options. Option 1, if your graph looks like this, that would be a normal distributed graph. So if it looks like the chart that we had yesterday, that curve, that's a normally distributed graph. Okay? If your graph looks like this, is that normally distributed?
No.
No. As maybe some of you do, now I see that Bailey's sweatshirt that she has on today, that's like the flight of a golf ball. Well, you hit the ball, it goes up, and then it comes down. It doesn't go like a perfect parabola. Okay, it goes up, and then comes down and lands. That would be considered skewed left. So if the picture looks like that, that's considered skewed left. And then, if it goes up and then comes down like that, that would be considered skewed right. Now, what you're going to do on something like that is they're going to give you a picture, and you're going to be asked to tell me what kind of distribution it is. It's either normal, skewed left, or skewed right. Okay? So, using this one right there, the graph says heights of women in the U.S. ages 20 to 29, which you will be soon. Is that a normally distributed curve, skewed right, or skewed left? I think that's pretty normal, don't you?
Yeah.
Good. Population of Brazil. Is that normal, skewed right, or skewed left? It's skewed right. That's what you're trying to tell me. You're looking at the graph and telling me which one you think it is. Final exam scores. That one. Skewed left, normal, or skewed right? Skewed left. Looks like that. Average miles per gallon for trucks. Skewed left, skewed right, or normal? I'd say that's pretty normal. maybe a right, maybe a little bit in there, but I'd say pretty normal. Okay? So for that particular part of the assignment, that's what you're going to do, is you're going to look at how does it compare and which type do you think it is. Now, again, this assignment's really small. It's only 6 questions. It's on page 601 to 602. It's 23 to 26, 28, and 29.